We'll start here. So as I said in the last session, we talked about mostly the different collections. We saw vector collections, we saw set collections, we saw map collections, and I also discussed about the options. Options is called as a monadic collection, and similar to options, there is either and there is try. Try catch is different. I mean, try catch is different. Yesterday we also saw try catch. I think I did not share that code. I will share that code. Try catch we saw, but try is also different. Try monadic collection is different. All these things can be used for error handling. But we only saw the options. Going forward, we'll also see either and the try. And we also saw a lot of methods that were available on the collection. Mostly the higher order functions we saw. But there are also other methods that could be used. So keeping these things in mind, I mean, we will go on to now object-oriented part of Scala. I mean, we have already gone through that object-oriented part of Scala here. So we have already discussed that. As I said, Scala is a pure object-oriented. So whenever we said x is equal to 10, we know that x is an object of type, or we can say class, integer. We have already discussed this. I mean, we have come across a lot of objects in the programming. But what we'll try to do is how a class is created in Scala. That we will see now. A simple class, how do we create classes in Scala here? I think 1 second. What I will do is all these examples are also there in the training. You can see the way the classes are created. You can use it for running it on your Scala shell. So I will showcase how to create a class here. So this is how we create a class. Class, give a name to that class, some members in that class. This is one member. First name, last name is also a member of the class. Greet, if you see, greet is a method inside a class or a function inside a class, which we call it as a method. The greet method does not take anything as the input parameter, and it returns string. I mean, we need not specify that. We can directly say in this fashion. We need not specify that it returns string. It is automatically inferred. So this is a greet function. It does it. This is a function I can define in this fashion. Or this is also not required. We have one more function, toString. We have one more function, toString, which is usually used to for how your objects looks like. Just to print how your objects looks like. That's where the toString method is always used. Most of the classes use this toString function so that they just want to know how the object looks like, and somewhere we want to use it for debugging purpose. Tostrings will be helpful for understanding or to look into the objects in a more human readable form. That's the idea of using the toString. So we have a class. I mean, all these things are not required. We have simple class. I will rewrite the class once again. So this is our simple class. Class user, we have a member first name, we have a member last name, and we have a method called greet, define greet, and we are just saying hello from the first name user. And we are having one more method called toString. This is one more method where we want to see how our object looks like. Our object should be in a human readable form just for understanding purpose. Or there is no use of that toString. It is only for understanding purpose how the objects look like. And we are using a override keyword here. So what does that override keyword mean? The override keyword means that this method or this function is already defined in some class. And which is that class? So as you can see, this is the hierarchy we saw earlier. And if you see, Scala classes come here. Any user-defined Scala class comes here. What it means is, by default, it is a subclass of any reference. And by default, we know that any reference is a subclass of any. So the toString method is defined in either of this. I mean, either it is defined, toString is either defined here or it is defined in any class. That's what I meant to say. This method is already defined. Since our class is a subclass of this, our class, whatever class we have defined, becomes the subclass of, by default it will be the subclass of any reference. Hence our class will also have a toString method already defined. but I want to override that definition. I don't want to use the same definition. Hence the override keyword is being used here. Hence the override keyword is being used. I hope you got the idea why the override. If at all you have any function defined already and you want to in your parent class and you want to override the definition of that, we use the override keyword. Now there are multiple things to know about whenever you define a class. I mean, it is similar to Java. I mean, it is similar to the way in object-oriented way a class is created. Some shortcuts are taken here by Scala as a programming language. Some shortcuts are taken. Some things are internally taken care by the compiler. We don't have to worry about that. So usually what happens whenever a class is created, there should be a constructor. The constructor is the one which helps you to create an object. Whenever we create an object, constructor is the one that gets called first. There should always be a constructor for the creation of an object. Now where is the constructor defined here? As we see that we don't see any constructor being shown here. But internally the compiler has created a constructor. Now how does that constructor looks like? The way the constructor looks like is in this fashion. So whenever we define a class in this fashion, internally how it works. Since it's a val, first name is a val. I have defined it as val, meaning you cannot change the value of first name. It will always be John. So internally what happens, it creates a member in this fashion. The compiler makes it as final. Final means you cannot change. It converts into a Java syntax because Scala is a Java based language. And also if you see, last name is var, hence it does not make it as final because you can change the value of var means you can change. So that's how the compiler defines it. Also you can see here the compiler internally creates a constructor. This is that constructor. So when you define a class in this fashion, the compiler creates a constructor in this fashion. I mean, I mean, you can also specify parameters here. When you define a class, you can specify something. You can also specify parameters. Since we did not specify anything, the compiler also will define a constructor without any parameters. As you can see, there are no parameters. Now, what will be the body of the constructor? How did it arrive it here? The body of the constructor is nothing but the body of the class, except for method definitions. As you can see, this is a method definition. This is also a method definition. Except for the methods, whatever exists in a class, everything will be the body of the constructor. So the remaining are these two expressions. So these two expressions will become the body of the constructor. That's how the compiler defines a default constructor for us. The compiler created this. and also it will create getter and setter methods. So if it is a val, it does not make sense to create a setter method. You don't have anything to set it. I mean, you cannot change the value, hence the compiler will not create a set function. It will only create a get function so that you can get the value of this member. And the function name will be same as, you can see that the function name or the method name is same as the member name. Since last name is a var, you can modify this, hence a setter will be created for that. For var, both setter and getter will be created. For val, only getter will be created. And the getter name will always be same as the member name. So you can see that this is the getter name. And this is the setter function. Slightly, I mean, the syntax is slightly odd, but you never use this. These are all internally created. Getter and setter, the constructor, these are all internally created. The way we access is very simple. So the this is how we create an object. I will say val John is equal to new user. So John got created. Whenever we say this, the internally created constructor gets called, which is nothing but this constructor gets called whenever we create an object. Due to this, first name is assigned John and the last name is assigned Mike. So it's already been assigned now. So we can check that as well. John dot, you can see that the name is John. John dot last name, we can see that the name is Mike. But if you see, we cannot rechange, we cannot change it to something here. We cannot change it because first name is Val, but we can change the last name. I mean, I will say we'll say last name is something else. We can change this because last name is var. It's a variable identifier. It's not a value identifier. We can check whether it has been changed. You can see that last name it shows as Alice. Now as you can see, one more thing we forgot is this. So you can see clearly here members and methods exist in a class. Member is always private, method is always public. That we have to keep in mind always. Internally what happens whenever I say class user, I say val first name, var last name, and I have some methods. Define ABC, define EFG, some methods. Internally, by default, the compiler takes care of making members as private. It will be members are private. Methods are public. Now, what do I mean by members are private means? Members are private means cannot access members outside class. I mean to say, whenever I say val something like this, John is equal to new user, I cannot say John, I cannot access it outside the class. This is the boundary of the class. This flower bracket, open flower bracket, and this close flower bracket. Outside this, you cannot access members, first name and last name. I cannot say first name. I cannot say last name. This should give a compilation error because these are all private members. That's what we mean by private here. You cannot access it outside the class at all. You can only access the public members outside the class. I said that, but if you see, I am accessing this last name. I'm accessing this outside the class limit. The class limit is from here till here. But as you can see, I'm accessing the first name outside the class. I'm accessing the last name outside the class. I'm accessing the class name outside the class. I'm accessing the members outside the class. Just ignore whatever I said. I'm accessing the member, last name, first name outside the class. Why it is not giving any compilation error? Any guess why it is not giving any compilation error?
I presume it is an object actually.
No, I mean, this is an object. John is an object. First name is the member of the class of this object. But I said that whenever first name member is created, it is internally referenced as a private member. This will also be private member. And I also said that private members cannot be accessed outside. First name and last name are private, but still we are accessing outside the class. We are still accessing the private members outside the class. It should have given us the compilation error. Why it is not giving the? Right. It is because this is not actually the member, it is actually the method. And I said that the compiler internally creates a method. The compiler internally creates a method, and the method name is same as the member name. The method name is same as the member name. So actually what we are doing is we are not accessing the member, we are actually calling the method which internally returns the value of the member. Here also the same thing. We are accessing the method which internally calls the value of the member here. Similarly, whenever I am assigning a new value, actually I'm not directly assigning it to the member. Internally it calls this method. Actually it is the method that I am calling, because the compiler internally has created a method in this fashion. So it is always accessing the public methods, not the private members. So I hope those things are clear. I mean, compiler creates a lot of things for you. We don't have to explicitly provide these things. Usually in Java we provide all these things. We explicitly write all these things. Setter and getter methods for every members. But here the compiler takes care of that. Similarly, in Java also, there is a default constructor, but here the default constructor is slightly different. We will see with the next example, the default constructor also gets changed. So what will define?
Pramod,
Yes,
internal, since as you mentioned, this is like a similar to Java. Internally, it will create like Java classes only.
right.
So will it not have any main thing,
Sorry, I didn't
main
get that.
main method?
No, main method will not be there. Main method,
Okay,
as only the developer writes the main method so that he can direct from where the execution should start. Otherwise,
okay,
classes are just templates defined. And finally, all these templates should be integrated and a project will be created. And after creating that project, we have to specify from where the execution will start. That's where the main method will come.
okay. Thank you.
Yeah. Now this is the way of creating a simple class. Just define class name, some members, and some methods. Now we can also create this. This I said is a default constructor, but we can also create our own constructor also. We can also create our own constructor. Let's let's see how it can be done. What I will do is I will not use this. So this is one more way of creating the class. I'm creating one more class here. As you can see, this time I'm having a parameter here. I'm having two parameters, fn, which is of the type string, ln, and which is of the type string. Those those parameters are being assigned to the members' first name and the last name. Everything remains the same. Everything remains the same. Only thing is we are having a parameter. Now, what does that mean? It means that now the default constructor has been changed. Earlier we had. Now what it means is the default constructor has been changed here. Now we have defined class user first name whose type is string. I have last name whose type is string. So I have val first name is equal to fn, var last name is equal to ln. Now internally what happens? Internally the compiler creates a user constructor in this fashion. Now this user constructor takes these parameters, and the body of this constructor is nothing but this as I said, it remains the same. The body of the constructor is all the expression in the class except the method. All the expression in the class except the methods. We know that these two are methods. Except these things, whatever we write is a body of the constructor. Obviously, this is our body of the constructor. This is the uh, input parameters to the constructor. This is the body of the constructor. That's how it will look like. So internally, it will look like something. I did not define that, but it's okay. But we know how it will be looking like. Internally, when I define a class like this, it will be same as this. Internally, it will look like the same. But here we will have, the only difference is this. It will be fn. This is how it will be looking like. Everything else remains the same. Only this is the way it looks like. So if you have to create a class, as I said, sorry, if you have to create an object, as I said earlier, the object is created only through the constructor. It will be always created through the constructor. So whenever you create an object, we have to pass the first name and the last name. Otherwise, we cannot create a object at all. So if you see, I cannot just say new user now, because there is no constructor defined without any parameters. There is a constructor defined with the parameters, then I have to send the value for that parameters. So you can see that John will be equal to, John dot first name is this, John dot last name is this. So it has been assigned. We can check that these two values, which are the parameters, are being assigned to this, because these two expressions are part of the constructor, and as soon as we create an object, the constructor gets called. Now I also want to create an object without passing any first name or last name as the parameter. Sometimes I want some default name as the first name and default name as the last name. Even if I don't specify the first name and the last name, it has to create an object. To make such things happen, now you cannot. You can see that if I just say new user, it will not allow you to create an object. It says that not enough parameters to the constructor, because the constructor takes two parameters. Now how can I achieve such kind of a syntax where the default some name and first name and last name will be assigned? So that's where we create a auxiliary constructor or some new constructors. We ourselves can also define new constructor here. So the way we define a new constructor is using this keyword. I'll just use this and put it in the class. So this keyword is used to create a new constructors, our own constructor. So as you can see, this constructor does not take any parameters, and internally it is calling the we are calling the default constructor created by the compiler. This is how we call the default constructor, and that constructor we know that it takes two parameters. So we are having some default name. We can say the default name are something Alice something. So if you don't give the username, first name and the last name, by default it will choose this. The idea here is to showcase how to create your own constructor. The only thing is, the very first expression in the body of this constructor should be a call to another constructor. That's the only rule it has. You cannot just say anything else in the constructor. I cannot say anything here. The very first expression, you can have println later. You can have println later. Here I can have println. Very first expression should be a call to another constructor. That's all. Here another constructor is nothing but our default constructor. That's what we are calling here, which will internally call the which will now what happens, one more constructor is being defined, which will look internally, it will look something like this, which will call user with default name. And this is how the internally looks like. This is how it will look like. Internally it will call the user whenever I write this. So if I redefine my class once again, let me redefine my class once again with my constructor. So now we can see that I'll just write Alice. Now we can only specify this. In this case, this constructor will be called, and which internally call our default constructor created by the compiler, and it will assign first name and last name with whatever parameters is being passed, which is nothing but Alice and Mary. Alice dot first name, if I say, so we get this. That's how it works. Now also, if you see, whenever I create an object, it always showcases how an object looks like. The shell always displays how that object looks like. This is because of that toString method. Sorry, this is because of the toString method where we are displaying the first name. We are saying user, that user is here, and inside user we are evaluating first name. So as I said, toString method is always used to how our object looks like, to showcase how our objects looks like, or it is made to make our object more human readable. If I remove that toString methods, it will you will not see such things. So if I rewrite my class once again without that toString method, let's see how it looks like. we will only have the greet method. Only one method will have. I did not redefine my toString method, but there will be already a toString method defined in the parent class. Now the shell will call that. Let's see how it looks like. Val, I will say Alice. So you can see here now how it looks like. It is not so human readable form. It is giving some memory address, that's all. The toString method, the default implementation of the toString method is to just give the object and its memory location, which is of not much use to us. So usually if you want to debug and you want to see how the object looks like, so it is always toString method is used. So which we had already redefined it to display how the objects looks like. That's the use of toString method, to give you a human readable form of how our object looks like. So here is a question. The question is, do we have to override the default constructor when we use parameterized constructor? No, I didn't get the question here. Thiru, can you explain it?
Uh, like we are passing parameter, right? To
Yes,
create an object.
correct.
So default, this is a default constructor. So
Correct.
which is again calling the class object class. Then it is passing the parameters. So we have to write like this. So define this, and within that we have to call this of the parameters. So this we will be writing, or it will
This we
the
have to.
compiler.
I mean,
Okay.
if you don't write this, there is only one constructor. That's the default constructor created by the compiler.
Right.
Takes two parameters. Now with that constructor, we can only create an object by passing the parameters
Okay.
in this fashion.
Yeah.
With default constructor, we can only create the object in this fashion. There is no
Okay.
other way to create an object.
Right.
So I
The
cannot. Yeah.
previous statement, val alias equal to new of customer. So this calls the this
Right.
constructor, and within that we are passing the values, right?
Correct. Now whenever I say this, now that will call this constructor.
Right. But okay. But we cannot override the values, right? Override the default values
Right.
defined
Overwriting
with.
the default values, then the default constructor will be called.
Okay. Right.
So we can specify any number of constructor of our own. We can Any number of constructor can be created. And now I want to only pass the first name. Let the last name be some default value. So I can create one more constructor to achieve that as well in this fashion. So as you can see, I'm defining one more constructor which takes only the first name. As of now, you cannot create an object by passing only first name. I cannot say Brad is
Right. Right.
equal to new user by only passing Brad, because there does not exist any constructor which takes only one parameter. Either it takes two parameters, or it does not take any parameter at all. Now if I want to create an object by only giving the first name, let there be some default last name. So if I want to achieve that, so again I have to define my one more constructor.
Yeah, I got it, Pramod. Thank you.
I'll just so now I can say I can specify everything. I can say val Alice is equal to new user without anything. It will create Alice. I can say val John is equal to new user. I can say both the parameters. I can also say val Brad is equal to new user with only one parameter. So all these things are possible now because we have different constructors, and one is the default constructor. So this is how you create an object by passing different parameters. So what I will do is, before I forget everything, this is class. I will just upload this. So now there is. I will upload this file to the Google Drive. So before there is one more way of defining a class. I mean, this is normal class that we define without any parameter, without any parameter. Then we define parameterized class in Scala. Now we can combine these two things together. So there is one more shortcut way of defining a class. So you need not specify fn and ln and then assign it to first name and last name. You can clearly see the difference. The difference is if you see earlier how I defined class user. I had said first name as string, fn as string, ln as string. So you can see that clear difference. We did not specify val earlier, nor we had specified var earlier. We had just specified fn and ln. And we had said val first name is equal to fn, and we had said var last name is equal to ln. This is how we defined our earlier classes. So we can make it more compact. We can make it more compact by directly specifying first name here. By directly specifying last name here. So this syntax is same as the previous syntax. This syntax is same as this syntax. We have just made it more compact by specifying val and var in the parameter itself. That's all. So now what it means here is, as I said, when we have val or var anything, it means that these are the member of the class as well as parameters to the constructor. So we are just compacting the way of defining the class. So I can say we use the parameter in this way. So I hope this also was clear here. Yeah, here is a question. The question is a class related members mutability and immutability. I mean, when we have val, it means it is a immutable. If we have a var, our class is mutable. Our class is mutable. That's the only thing we have to remember. With respect to class mutability and immutabilities, that's all. We define a class with val, it becomes immutable objects. If you define a class with var, you create mutable objects. An object can be modified. That's the only thing we have. So for immutable members, or we can say for immutable members, you will only have getter method defined. For mutable members, both getter and setter method will be defined, because setter makes sense only if you could modify. Hence, mutable members will have setters and getters. These are the only difference that we have. So internally, as you can see here, this is how the internal definition looks like. First name, last name. First name will be set as final because, and it will have a constructor in this fashion. And this is all the setter and getter methods. We have a greet method and we have a. So I hope, Mohan, that was clear. There is only val and var, and there is only getter and setter methods. So I will just showcase this example. As you can see, now we have made it a more compact way. We have made it a bit compact way here. Let's specify these things. So I can create a val. I will just say John is equal to new user John, last name as Mike here. So it internally creates a new user, which is nothing but the members are first name and the last name. And they are also treated as the parameters to the constructor. A bit a compact way of defining a class here. So what I will do is I will just upload this file. You should be able to see it in Scala. Class definition. So that's how you create a class in a in 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 in, in Scala. Again, we'll be looking into more such things as we move on with our Spark examples. We'll be making use of how to use a class there. So, but that's the simplest way of how to define a class. The things that we learned is how the compiler internally creates lot of things, and as a developer, we have to just create the minimum things that were required. The members constructor is automatically taken care. If you want our own constructor, we use the this keyword. Setter and getter methods are already taken care. Members are also made private by default. Methods are made public by default. So these things we have to keep in mind.
Pramod.
Yes.
Yeah, in Java, actually, we'll be creating, we will be writing our code and we'll be saving it with .java. And
Right.
when we compile it, it create a .class file. So how
Correct.
will it happen in Scala?
We will see that
What will
here it will happen. Here we'll create .scala file. You can see here it is all not Java, it is .scala. Now when we compile, here also we'll get .class file. After the compilation, it will be same. That's what I said. Internally, the Java, how it looks like. Internally, it will create the .class file, which will run on the JVM.
Okay, thank you.
So next we were about to see those things itself, how to write in the Intellij. So this is how we define a simple class. I will also write down certain points here. val means final member. For val member, for val member, only getter method is created. For var member, both getter and setter method is created. This keyword is used to create auxiliary constructors. New constructor, we call it as auxiliary constructor. Members are private by default. These are the things to remember. Methods are public by default. Getter method name is same as member name. So these things we have to remember about class. So I will just upload this. I will delete the earlier one. Let me remove this. So you should be able to know things from this. Next what we'll see is, next we'll see objects. How an object is created. That's the new thing again in Scala. What is a object here? Object keyword is being used here. So to understand these things, now we'll shift to Intellij. So if you are using my image, you should be able to see this. If you are using my image, just go to the dash home, the top icon on the left panel, click on that and search for Intellij. Just type int, you should get the Intellij. Click on that, the Intellij should open. So this is our programming editor. Intellij is similar to Eclipse, but a bit lightweight, hence I'm using Intellij. If you are comfortable with Eclipse, please do use Eclipse. If you are comfortable with Intellij, yeah, here is a question. The question is, if Intellij has to be installed, do we need to configure anything? Slightly, yes, you need to configure something. So what you have to do is, first of all, you have to download Intellij. Just say download Intellij. JetBrains is the company. JetBrains is the company behind Intellij. So just click on that link. So it will show here. If you are installing on Windows, you just download the Windows. If you are installing in Linux, click on that Linux. If you want to install on that Linux, click on that in Linux you should see a tar.gz. Download the community edition, sorry. Download the community edition, which is free version. It is also tar.gz. Once you download this, it is around, I don't remember, 400 MB or somewhere around that. Just download that into your Linux machine. So as you can see, I have downloaded it into. So it will download by name something like this with tar.gz. It will download as a tar.gz compressed one, but the name will be almost same, idea.ic, and the version number will change with compressed like tar.gz or something like that. Right click on that and extract it. Right click on extract it. Now this is how I got extracted. So it will create a folder by this name after you extract that. So once you have that, I'll close this. Go to that folder. Once you extract it, go to that folder. This is the folder name. Based on the version, you may get 16 here. Mine is 14 version. You may get 16 because latest is the 16. Inside that you will see bin folder. Go to that bin folder. Inside that bin folder there is idea.sh script. You need to run that script. This is how you run the script. // run the script. As soon as you run the script, for me it will open as it is because this is not the first time that I am opening. For you it will give an option whether it is the first time you are opening it. So click on that option. Yes, this is the first time. Then it will ask some default things. So let me check whether I have somewhere stored those things. So I think I have it here. So as I said, you run this. This will pop up Intellij installation window. Keep pressing next with default configuration. It will ask to install Scala plugin. Click install and then press again next and finally finish button. That's all we have to do. Only new thing that you are doing is Scala plugin, install Scala plugin. There will be a button which showcasing install plugin, Scala plugin. So I will share this document, install and code setup on Ubuntu. So I have to share this to everybody, right? So what I will do is I will send a mail probably, because I will share once for all the folder in one go instead of sharing one folder. In one go I will share all the folders. As of now, what I will do is I will send this as an email document. So that could be used for. I have also explained how to import the code. How to import the code. So once you install the IntelliJ, you should see this. Once you install IntelliJ, you should see this. But if you are using my image, the IntelliJ is already installed. It may directly open some project. If you are using my image, it may, as soon as you open IntelliJ, it may open some project. What you have to do is, the very first thing, you need to close the project to get back to that window. Don't exit. Most of the people try to exit, so just don't exit. There is an option called close project. So there is an option called close project, just close project. You don't exit. So when you close project, it will give you this window. I mean, if at all it has opened multiple projects as soon as you open IntelliJ. Just close the project and come to this. Once you are in this window, I have some Scala examples in my Scala folder. So if you go to my Google Drive, Scala, I have already shared the Scala folder. Download this sptprojects.tar.gz. Download this and untar. Download and untar. You should be able to download from this system. Downloads, there should be some SPT projects. I mean, you can download it anywhere. It will be something like this. Scala Examples.tar.gz. Just right click on that and you just say extract here. So when you say that, you should get such folder. Once you have a folder like this, once you have this folder like this, go to your IntelliJ, click on import. Just click on import. Select that untarred Scala folder. So I have untarred it inside downloads, SPT projects, Scala Example. Just select that. Click on import. It will pop up a browsing window. go wherever you have downloaded that Scala example, select that and press OK. It will give you this option. It will give you this option. It is not a Maven project. It is a SBT project. Maven and SBT are build tools. They are used to compile your Scala programs. People either prefer Maven or people either prefer SBT. I mean, it's an individual choice. Maven is based on XML based build tool. SBT is Scala based build tool. So either we can use one of them. In some cases I'm using SBT. In some cases I'm using Maven. So in case, select that. For Scala it is SBT actually. Select that and you should see press next. If you are not seeing this, if it is larger than this, go to the view, make it as full screen. Okay, in my full screen also there is, I mean, you should see here, recently I changed something, then press next. Select use auto import, check mark that, and the button that is highlighted is finish button. Just click on that finish button. That's all. For SBT only I need to, it is only two windows that will appear. For SBT only two windows. Import, select the folder, press OK. It will pop up SBT. Next, checkbox use auto import and finish. That's all. Once you click on finish, I will not click on that. It will start downloading all the libraries that is required for Scala. Anything that I have put inside, everything will be, I mean, initially it will take some time because it has to download SBT. It will take slightly a bit time. Once everything is there, you should get this structure. You should get this project structure. The document that I have shared, the document is for Maven project. It is not for SBT project. Because my Spark example are based on Maven. Hence the document Intellij setup and import, code import is for the Maven project, not SBT. But for SBT, it's only these two steps. That's all we need to specify. I mean, don't worry about this. Now our goal is to understand. Now our next concept to understand is objects. Now what is objects here? So object is a keyword used to create singleton class. Now what do we mean by singleton class? A simple way to say a singleton class is nothing but a class for which you can create only one object. That's what we mean by a singleton class here. You can create only one object. You cannot create more than one object for this class. So we can achieve it through normal programming stuff. We already know that in Java, usually the way we do it, they create a constructor, they make the constructor a private, and some other stuff they define a function, some things they do, not to worry about that. Programmatically we can achieve that. But what in Scala they have done is, if you want to achieve such thing, they have put that into the compiler. I mean, as a developer, we don't have to worry about creating a singleton class. it is taken care by the compiler, and they have just exposed a keyword called object. That's all. So you can just say, just like we used to say, class user, and we used to say like val first name, something like this. We had, instead of this, we just say object user. That's the object keyword. That's object keyword. Now there is only one object, and the object itself is user. Now you cannot create more than one object. This itself is an object now. User is an object. In this case, user is a class. Here we can create multiple objects of this class. But here, user itself is an object in this case. Internally, the compiler will create a class, and this is the object of that class. And you don't have access to that internally created class. There is no access to that. You only have a object in this fashion. And anytime when we want to create an object, we use a object keyword here. We will see the use cases of how where the objects will be used. One of the use case of creating an object is to have statics. Now what do we mean by static here? What do we mean by static? So usually what happens, static is nothing but whenever you want to share something. So if I have a user, a simple example is I have user. I want to see how many users are being created. I want to just have a count on how many users are being created, how many user object has been created. Usually in other programming language, what we say is static count. We say static count. Something, let's say val. Here we don't have, in Java, in Scala we don't have a static keyword. Usually this is how it is done. We have first name, we have last name. Now whenever I create val user1, so inside user1 there is this first name and last name. It's the instance variable. For this user, there is a separate first name and last name. Whenever I create user2, again user2 has its first name and last name. Similarly, user3. Similarly, whenever I say user is equal to new user, whenever I say, this first name is its own copy. It is not the common copy. Every user has its own copy of the first name and the last name. Those we call as usually instance variables. For every instance, we have a member. Instance members we say. First name and last name, and so on. Now this count is common. So we can say there is one count. There is only one count here, and everybody shares that count. There is only one instance of the count. There is only one instance of the count. So this is how you want to share something for each user. So using this, we can know the number of users that has been created. We can, as soon as a new user is created, we can just say user dot count is equal to plus 1. As soon as a user is created, we can increment this. So from that, we'll be able to have this is what we call static. It's always used to share that instance with all the users of the class. There will be no individual copy, it's only one copy. That's what we mean by static. But in Scala, we don't have a static keyword. In Scala, we don't have static keyword. Then how do I achieve a shareable member? How do I define a shareable member? So that's where the object comes into picture. I define object, some ABC, something. If I define some members inside this object, now we know that object ABC means there will be only one ABC now. There will be an object ABC. You cannot have more than one object of ABC. Since there is only one object A, B, and these members, there will also be only one copy of this ABC. Now A and B, these are the members. These also will be only one copy because the object itself will be only one. Hence the members will also be there exist only one copy. So this property is being used to achieve static. But this has to be incorporated inside a class, because for a class we need to make this property, make use of this property of an object and achieve static. We haven't achieved the static yet, but we know that an object, there will be only one object, hence the members will also be only one. That property can be used to achieve static. So to achieve static with object, so we have to define something called as companion class and companion object. So whenever we use companion class and companion object, only then the objects can be used as a static for that class. Usually the statics will be for a class. You have to define static member inside a class. Now we make use of this object concept and achieve that. Let's see how we achieve that. So now before achieving that, we have to say what is companion class and companion object. So if we define an object and a class with the same name, if class and object has the same name, then we call it as a companion class, and that class is called as companion class and that object is called as companion object. Class and object can have same name. Class is called the companion class. Object is called the companion object. One more requirement is the class and object must be defined in the same file, in the same .scala file. Class and object must be defined in the same Scala file, otherwise they are not companion class and companion object. So using this property helps us to achieve, object property as well as this companion. Combine these two together, we should be able to achieve static. So let's see an example here. So if you have opened that project, you can open it later as well, just importing. So you should see such structure. You should see such structure. Click on these structures. Go to the source folder. Inside source folder, go to the main folder. In the main folder, go to the Scala folder. Inside the Scala folder, you should see com.datamantra folder. Inside that, you should see companion objects. So just let's see an example of the companion example here. So this is a companion example. Yeah, let's see the companion example 1. Companion example 1. Click on the testing here. So as you can see here, I have defined a class called secret agent. I have defined an object also called secret agent. So as you can see, the class name and the object name are same. Hence, this is called companion class and this is called companion object. Now, because of this, what you can do is you can access all the private members. I mean, this object can access any private members that are defined here. Any private members. If I say var b, where ABC is equal to something. So this object can access these private members. If I say private. Similarly, any object I create of this class. Just like if you see this object is being created of the class. Now this object can also access all private members of this companion object. I mean, what I'm trying to say is when you have companion class and companion object, the companion object can access the private members of the class, and the class object that we will define, those also can access the private members of the companion object. Vice versa, each one can access one another's private members. That is one more property of using of companion class and companion object. Now all these properties, whatever I'm saying, an object, anything that we define an object, inside that there will be only one copy. Then we said companion class and companion object. When we have companion class and companion object, each one can access one another's private members. You need to just remember these properties. Using these properties, we achieve the staticness here. So before I go forward, there is a question, can we use members of a class inside object? I mean, you can access. But you need to define an object. Through an object only we can access. Do we need to use private keyword when it is already a member? Yeah. So there is a question, why are we using private keyword here? Why we are using private keyword here? So what does that mean? So if you remember, I said that members are private by default. Then what does this mean? What does this mean? When this member is already a private, what does that private mean? I think Mohan's question is also the same. What it means here is, this means getter and setter method is made private. Now you cannot access member B not through getter and setter method, because getter and setter method is also made private now. Now I'm doing all these stuff to explain static. I'm doing all this stuff to explain the static here. So this part of the question was clear, I suppose. Mohan, whenever we say private, we are actually making getter and setter method is made private. Now we need to see why we are doing that. Why we are doing that. Now the question is, sorry. So we'll come back to this. One is we are defining companion class and companion object. This is called a companion class and this is called a companion object because both are defined in the same file and both the name are same. Hence they are companion class and companion object. Now whatever is defined inside an object, this we can treat like a single instance, single copy only, which helps us in defining a static member for this class. Now since this is accessible, B is accessible inside the class, because as I said that a class can access all the private members of the object. So we can make use of this as a static member for our secret agent class. So let's see how we are making use of that. Now I am creating bond as a new secret agent. One object of this class has been created. An object of this class has been created. We have a class, we are just creating the. Now since B is nothing but, I will say it as bullets. I'll rename it to bullets for more readability. B is nothing but bullets here. So we have defined a bullets. So we want to share these bullets among different secret agents. We have, as of now, that's how that sharing. There will be no individual copy for every secret agent. Every secret agent has to share among these 3000 bullets. Hence we are making it as a member inside the object so that it becomes a static. Now let's see how it becomes a static. We are creating a bond here. This is one secret agent. I'm having one more Jason Bourne as one more secret agent. Rajnikant as one more secret agent. Now we have a shoot method inside our secret agent. We have a shoot method in our secret agent where we specify the number of bullets he wants to shoot. So internally what we are doing, we are how much he might have shot some 10 bullets. Those 10 bullets will be decremented from our total count. So that's this method. This will decrement the total count. It will keep on decrementing the total count. As soon as somebody fires some 10 bullets, 10 bullets will be decremented. Now as you can see here, we have a shoot. You can clearly see that we are accessing the private member. This is our secret agent object. The way we access a members of an object is just use that object name dot member name. So I mean to say, if I have object ABC and I have members called val A, val B, and val C, the way you access the members is, since this is already an object, we just say ABC dot A, we just say ABC dot B, we just say ABC dot C. That's how we say it, ABC dot A, B, C. Now we are accessing this secret agent dot bullets. We are able to call this method decrement bullet. We are able to call this inside our class. Accessing private member of object so that's the you cannot do this if at all it is a some other class. If I define class ABC, if I define class ABC, so you cannot say secret agent dot bullets. You cannot access. So as you can see here, symbol bullets is inaccessible from this place. I mean, why it is inaccessible? It is inaccessible because the getter and setter methods are private. You cannot access a private member outside the class. You can only access private members in the companion class and the companion object. Only companion class can access it. Otherwise what will happen, these bullets can be made static to any other class also. There will be no restriction that these bullets could be shared with CI. I will just showcase an example. Why that statics, all those things we are coming into picture is, let's say I define one more class called CIA agents. I don't want to share those bullets with the CIA agents. I don't want to share those bullets with the CIA agents. So obviously it will not allow us to share. Otherwise, everybody will take that static. That's the idea of having making it as private. That's the idea of making it as private, so that only companion class and companion object, only companion class can access this. So that this member becomes static to only this class. It becomes static to only this class, not every class. Not every class. I don't want to share. Otherwise, everywhere we define a class, I can define any number of class then. So that we need to make sure. If I define one more class as raw agents, they also cannot access that bullets. If you make it as this, so now you can see that you can access that. Raw agents can access, everybody can access these bullets. This we don't want to happen. I want the static to only for one class. That's the reason we are putting a private here. That's the reason we are putting private, so that not every class shares this instance. Not every class shares this instance. That's where we get these errors. Just comment this. Now since this is defined inside an object, there will be only one copy. Every object of this class, every object in this class will be sharing that. Now why the private has been made, so that no other class should be able to share this. Because only private members can be accessed from the companion object secretly. So decrement is also private method. We made it as private so that only companion class can access it. We made bullets also private, only companion class can access that. So it makes now more simple. We have new secret agent, bond, boss. All of them are shooting. Some are shooting. Some bond requires 100 bullets to shoot. Born requires 500 bullets, but our Rajnikant requires only one bullet here. So, but all these things are shared. All these things, bullets is being shared here, and that's the use case of companion class and the companion object to achieve static for a particular class. You want to achieve static for a particular class. Good thing is, you can put all the statics in one place. Whatever you define inside a class, any member you define, since there will be only one copy, everything we can make it as a static. One good thing is, like, all statics are at one place. We just have to see the object, we will come to know that all these are statics. The way we make it as static to other class here, so define a companion class. So now bullets is a static member of this class, we can see. Bullets is a static member of this class. This bullets is shared by all the objects that is created by this class. You cannot share with by to some other classes. That's the reason we have made it as private. That's the reason we have made it private, which makes getter and setter method private. You cannot access the getter and setter method also now, because it is being made private. It cannot be accessed outside except in the companion class. Except in the companion class. So I hope the use case of companion class and companion object was clear. This is one of the use case. I mean, we have to put lot of things together. We have to know what is an object. Because of object, there will be one copy. Because of companion class and companion objects, you can access the private members. And that private making a member, the static member private, we restrict that member being accessed somewhere else. So if you put all these things together, then we achieve static. Then we achieve static. So I mean, a slight tricky here to grasp these stuffs, but this is the use case of static.
Pramod, is this object also is a kind of instance of any class?
Right, it is internally created class. I mean, we don't have access to that. We only know that there exists a object, that's all.
And so you mentioned that the class and the object, the companion class and companion object should have the same name.
Correct.
So then only it can access the private members and methods.
Right.
So what if I create some 3 different classes with with the name secret agent only, but the parameters differs with different kind of parameters. So will all the 3 classes be able to access the objects from the methods and members from the object?
So you are saying, I never tried that class secret. agent let's check that. Symbol is inaccessible in this place now. Is it because of this? As soon as I create, everything is lost. Usually we don't do that. So you only define one companion class. So I think whichever is at the top level, it is taking that into consideration. It takes the first defined class. Usually we usually define one companion class and one companion object. It is only taking the first one defined. If I put this one as the first definition, it will take that into consideration. The other one, it will not treat it as probably not as a companion class. This it is not treating as a companion class. Hence it says symbol decrement is not accessible. Symbol this is not accessible. It will just treat it as some other class. That's all. I mean, even I need to look into this. What actually it is happening? What actually it is happening? No, it may not be because of singleton, because object is singleton. This is the class. Object is singleton.
And does it depends on the order within the same file, Pramod? Because
Yeah. I
when
think,
we create a project, so it can be in different files, and the main will call in an order kind of thing, no?
yeah. I mean, the requirement for companion class and companion object is they have to be in the same file. Only then they are companion class and companion object. Otherwise, they are normal class and normal object. There is no relation among themselves. If you define it in the same file, only then they are companion class and companion object, in which case they can access the private members and methods.
Okay. So then in this case, I mean, what kind of object is the testing which you have created at the bottom?
Right. That is where I define the main method. This is one more object. We will see. I mean, we know that how usually main method looks like in other programming language. We usually say, especially in Java, main is defined as public static void main. This is how you define a main. So main is if you see, is a static method of a class. So since main is a static, we usually define it inside a object. That is one more use of a object keyword. Your start of your entry point, your main method is always defined inside a object. This object is totally different from this object. This object we made it as a companion object of this class. This is our new one more object where our entry point starts to the application. Any application you will see in Scala, The main method will always be defined inside the object because main is a static. The entry point, always you need to define an object. Inside that only you have to define your main method. Which earlier what used to happen is in other, especially in Java, we define main methods inside the class. An object of that used to be created and the main method would have been called. I mean, the JVM used to take care of that. Now here we have to define the main method inside the object only. That is one more use of the object keyword here. I mean, there is no relation here. There is no relation between the companion object and this object. This is one object. This is some other object. That's all. Since main method is static, we define it always inside a object. So I hope that was clear.
And the main method always requires any parameter, that string parameters?
Yes, this is the standard syntax of main.
Oh.
So that from outside the, whenever you start your application, you need to give some input parameters, suppose. So that's where the arguments is being used.
Okay, thank you.
So those things are we need to remember here regarding the objects. Class and objects can have the same name. So whenever member is defined inside an object, only one copy of the member exists. This is what I said. Whenever defined inside an object. Companion class and companion object can access one another's private methods and methods. Above two properties can be used to define static member to a class. So this is the use case. This is one of the use case of objects, companion class, companion objects put together, we achieve static. The third point we need to remember is main method is always written inside an object. Because main method is usually looks like public static void main. Main method is as a static method, hence it will be written inside that. So the objects, some more use cases are there of the object. One is you can define lot of methods, utility methods or helper methods inside an object and then use that as a module. That whole object can be used as a module so that some application make use of all the methods that are defined. The utility methods that are defined inside that object, we can make use of those methods. We'll see that. I mean, this may not be required, but I will try to showcase this also an example. Companion class, companion object, and apply method is used to define factory design pattern. We will see that. We will see that. Some more things are pending on the object side. Then we will say case class. After case class, we will see traits and finally implicits. So let's wind up the session here and let's continue tomorrow same time. Thanks everybody. Good night and have a nice day.
Thanks, Pramod.
Thanks so much.